The theory of relativity proposed in 1915 by Albert Einstein comprehends two of his previously proposed theories on general and special relativity interrelated. This theory is divided into four main parts: classical relativity, general relativity, special relativity which includes time dilation and length contraction, and the illusion of time. Classical relativity. Einstein determined that the laws of physics are the same for all non-accelerating observers. It states that no object is in absolute rest or motion. All objects are moving relative to one another. General relativity. General relativity applies to situations where gravity is taken into account, whereas special relativity applies to situations in the absence of gravity and when objects are moving at constant speeds. The theory of relativity argues that space and time are interconnected in the absence of gravity, forming space-time. Space-time can be considered as a sheet of fabric. Einstein states that considerably large objects warp the fabric of space-time, which creates distortions which in turn produce gravity. This can be visualized. When you place a bowling ball on a trampoline, it would create curvature, and this is the distortion. According to Newton's law of gravitation, large masses have greater gravitational force as the force is directly proportional to the product of the masses. But according to Einstein's theory of relativity, it is because larger masses warp space-time substantially, producing a larger gravity. Special relativity. Time dilation. Speed of light is the same for all observers regardless of the distance it moves. When objects are moving close to the speed of light, time tends to slow down in order to maintain a constant speed. If we consider the equation speed is equal to distance over time, as the distance increases, the time has to decrease to maintain the constant speed of light. Time is relative, it is not a fixed unit. Special relativity, length contraction. When objects are moving close to the speed of light, as we saw previously, the time slows down to maintain the speed of light. But this alone does not occur. The distance of the object also contracts, which means that the size of the object is smaller compared with its size when it's at rest. This means that as the object size decreases, the distance the light beam has to travel also decreases. In summary, time dilation and length contraction occur simultaneously to ensure that the speed of light is constant. The illusion of time. According to Einstein, time slows down for objects traveling close to the speed of light, completely stops for objects traveling at the speed of light, and tends to move backwards for objects traveling beyond the speed of light. So far, nothing other than electromagnetic waves can reach the speed of light, as on approaching the speed of light, the mass of an object increases, which requires an infinite amount of energy to propel it at light speed. This is why a mass cannot reach the speed of light.